Hello, my name is Jared Oxstein and I'm going to focus on how mathematics is used in architecture. Mathematics is used in almost every facet of life, including but not limited to economics, sports, architecture, astronomy, geology, and engineering. We rely heavily on architects in today's society. Architects are involved in designing the interior and exterior of buildings, renovating and restoring significant structures, and the building of bridges and towers. They must ensure that the structure is safe and can withstand pressure from both the inside and outside, which may include weight, wind, snow, earthquakes, and rain. The size, shape, height, proportions, and all connections of the structure require mathematical calculations to assure accuracy. Math ensures that the structure is stable and will be able to stand. Without math, architects would not be able to construct blueprints. Blueprints are used by construction workers to bring the image to life. A blueprint documents the design and is a drawing to scale of the layout of the entire structure. They contain detailed information about the size and numerical equations that will be involved in the construction. Blueprints assure safety and balance, two things that are very important when it comes to a large structure that could, if built incorrectly, potentially harm or kill many individuals. The six tree functions include sine, cosine, tangent, cotangent, secant, and cosecant. The six functions help architects determine the length of the angle at which the structure should be built. The lengths of the sides of a right triangle and the angle between those sides have fixed relationships. If at least one side and one angle is known, the other angle and length can be determined. The three angles in a triangle will always add up to 180 degrees. This will be important when building roofs, stairs, and rooms inside buildings. The forms and shapes can be described in numerical equations which will help ensure the corners and the walls are all built correctly and in the right area. Trigonometry is used on a daily basis by architects to find unknown angles and unknown lengths of sides in triangles. Smaller angles involve less material, whereas steeper angles involve more material. An architect will use the law of sine if they know the length of two sides and the angle opposite one of the known sides, to calculate the angle opposite the other. The law of cosine helps to calculate the length of one side of a triangle when the angle opposite that side and the other two sides are known. The law of sine says that in any given triangle, the ratio of any side length to the sine of its opposite angle is the same for all three sides of a triangle. This is true for any triangle, not just right triangles. The law of cosine is used in any triangle when given three sides or two sides and their included angle. In the example, we can determine the length of the building using the law of sine. We can begin by noting that this is a right triangle, meaning angle B is 90 degrees. We know that the angle A is 45 degrees because it is an alternate interior angle. Because we found angle A and angle B, we can now determine angle C. Angle C equals 180 minus 90 minus 45, which gives us 45 degrees. We can now use the law of sine to determine the length of the building. Labeled ground. The length of the building divided by sine of angle A equals 120 divided by sine of angle C. Upon completion of this calculation, one can determine that the length of the building is 120 feet. Architects must calculate the exact angle of intersections for the different components of the structure they are building. Knowing the correct angles will help to ensure both stability and safety of the structure. Examples of this include roofs, slopes, suspension bridges, and support beams. Using trig to find different angles will help the architect determine how much of a particular material is needed to construct it.